and check. As with every other calculation, we would launch from the TEDS library access system, My Calculations. Click on it, insert in the document. Calculate section. British standards or Euro codes. Select the profile. I have 30 plus manufacturers, but for the example videos we're using the generic profiles. This time we selected 100 by 1.2. The building, for the example, is 10 meters square and happens to be 10 meters high. Again, purely for ease. 2.5 meter story height, 4 stories, 10 meters. Studs are at 600 centers. 2 walls in each direction, external walls. We'll calculate the wind load elsewhere, preferably using our Breathe software. We used 0.7 kilonewtons per square meter, so 10 meters by 10 meters high times 0.7 is 70 kilonewtons. The maximum axial load taken from the analysis elsewhere, this is for the lambda crit checks, sway P delta. Put in the roof load, permanent and variable, same with the floors, wall, etc. This is for the calculation for the overturning flipping check. And then we use industry standard is 4.5 kilonewtons per bay from SCI test data. If the user wants to change that, they're more than able to. We're sticking with the 4.5 for the example. Click on Finish. Calculation produces all the required information. Not much in the progress log. We have the building dimensions. We have the loads that are applied, details of the profile we selected. Little discussion on the principles of racking. The horizontal forces used per bay. We calculate the fixing capacity to resist the uplift minus the self-weight counteracting. Then we calculate the number of bays required to resist the wind blowing on the long face and on the wide face. We do this at every floor, top floor, second floor, first floor, ground floor. We tell you how many bays are required and also how many meters a basin that equates to. We do the overturning check to make sure it's not going to cockle over, not blow over in the wind. And we also do a sliding check to make sure that it won't slide. If it does, it tells you that we'll need so much and so many fixings, but because that's not the case. Because we're designed to the British standards, we have a sway P delta. If it was Eurocode, it would be a lambda crit. Shows that it passes, and that's finished. Thank you for watching.